Is there any hope of sorting out these different models by looking at other star systems and examining? Because, we learned a ton when we started studying other planetary systems. We kind of learned that our solar system was actually quite an outlier in terms of the organization and so forth. I wonder if we'll have similar revelations when we're able. Are we able to look at other heliospheres or?
Yes, we call those astrospheres, and we can see them in, I think, UV, X-ray, maybe visible light, I'm not sure. Depends on the gas around it that causes the light emissions. And some of them have such long tails, like parsec, much longer than we expect ours to have. The longest simulated heliosphere helio tail that is predicted is maybe 3,000 AU long. Part of the problem with understanding how long it is that our only direct observations are with ENAs. But the process by which ENAs are created depletes the plasma of those energetic particles. So you can imagine that as the plasma flows down the heliotail, it's creating ENAs, but it's losing these particles and being replaced with lower energy particles. So at some point, we're no longer going to be able to observe ENAs. They were all created.
Elaborate on that. I don't quite. They're not constantly being.
They're just losing energy, essentially. These transactions are building up, and they're.
When you say we're no longer going to be able to see them, you mean in terms of as you look farther and farther away from the sun?
Yes.
I see. Okay,
further down the heliotail, the plasma is essentially cooling, and we can no longer see ENAs, energetic particles, around a keV. And
that makes sense. Yeah.
They're going to be so low energy that they're being observed. Either they could be observed by the IBEX low instrument, which measures between about 15 eV up to 2 keV, but it has more issues with statistics. So we really try to use IBEX high observations to the best as we can. And it turns out that we can say that a minimum distance of the heliotail is 350, 400 AU from the sun. And by that, I mean not actually distance to the heliotail, but rather distance to the edge of the ENA source region that we could observe. However, there are two observations, completely separate observations that have more than hinted that the heliotail is long. One is Lyman alpha observations from stars, that if you happen to have an obstacle between you, the observer, and a star, I don't remember what star is near the heliotail. I think there was a study on this. They could tell that the heliotail was messing with their observations. Like if you look at neighboring stars away from the tail, you see a very specific emission lines. But if you look down the tail, it's obviously distorted because of a very long structure. And I think they could say, oh, it's has to be pretty long for it to mess with these observations. One of my favorite is galactic cosmic rays, specifically TeV energy cosmic rays. There have been studies that show that if you look at these cosmic ray anisotropy maps, which are basically maps showing differences in intensity of these cosmic rays in different directions of the sky, you'll see a little spot near the heliotail, or sort of connected by their trajectory to the tail, that can only be reproduced by simulation that has at least a few thousand AU length tail.
Wow.
Yeah. So,
but that's relatively small compared to the stars that you're saying have a 1 parsec tail, because I just looked that up, and that's 200,000 AU.
Yeah.
And so
It's just completely different star. Maybe that the one that has a huge tail also is moving a lot faster than we are. Could be many different things that could differentiate other astrospheres to ours.
How many AU is it to the next star?
I mean,
Anybody? I guess we could Google that. I'm just curious.
Light years is what, 4 or 5 light years? Was that right?
Yeah, but how does that translate to AUs? I'm sorry.
I
don't know the conversion.
Proxima Centauri is the closest star, right?
How many AU?
Hold on 1 second. So it's 4.2 light years.
I'm just curious.
I know the conversion from AU to kilometer, but I don't know parsec to AU.
So that is 4 light years is 265,000 astronomical
Yeah,
units.
so it's like it seems like these heliospheres could be directly interacting with each other in that case. Like the tail could be brushing up against the nose of the next. I mean, in these extreme cases, at least.
In some, it could be possible. I don't think it's happening with us. But
okay, so yeah, that's the question, because there's the heliopause and there's the bow shock. The bow shock is on the interstellar medium side. The heliopause is on the sun side.
Oh, the heliopause is the exact boundary between the sun and interstellar side.
Interesting. Okay, so is there something that's
solar
before?
wind or heliospheric termination shock is on the sun side. Yeah.
I see. Okay. Oh, yeah. Okay, I can see that now. So there's basically...
And we're not sure even if it's a bow shock. We think it might be a bow wave.
Interesting. Okay. But the question is when we say that it's the interstellar medium that it's the bow shock or the bow wave is in, we don't think that it's the medium of another star? Like we treat the stars as being within their own little envelopes that are separated by true interstellar medium that is completely separated from them, or do we treat the stars as impinging upon one another?
And as far as I'm aware, at least in our location in space, we are separated from any influence of other stars.
How difficult
in this sense?
How difficult would it be to look out onto the sky and to create a map of the boundaries of, 1,000 stars that we can see, that are the brightest stars in the sky?
Like astropause boundaries?
Yeah, exactly.
Oof. I only know of a few examples where you can actually see it, and those are the very extreme long ones.
I wonder if you could estimate it by various parameters related to the solar wind strength of different stars.
I mean, because it's so big, it's surprising that you can't see it for something. Am I just completely misconstruing the level of resolution that we have when we look at stars that are far away?
Well, this particular example of astrosphere is probably very far away. So even though its tail is long, if you actually just put it on a map on a screen, like the gravity wave map or cosmic ray map or our own IBEX maps, you probably couldn't even draw it.
So it's really, really. Yeah, I mean, it's hard to consider distances. There's that scene in I think it's in The Hitchhiker's Guide, where Zaphod Beeblebrox goes into the infinity machine and he's like forced to contemplate the size of the universe, and it's normally something that breaks people, but he just walks out totally fine. I feel like I have a really hard time just thinking about how big it is.
Well, and the interstellar structures are so tantalizing too, because there's this Oort cloud hypothesis, and I'm curious how that plays into this paradigm as well.
What's the Oort cloud hypothesis?
Well, it's hypothesized that there's some objects that extend further, like almost halfway to, like there's a wall of structures, little or big icy balls of things, right? This is supposedly a reservoir for our comets, and they can extend nearly halfway to, or it's thought to potentially extend halfway to the next solar system. And so if you start thinking about all the stars, if they all have Oort clouds, you really end up with this interesting web of stuff that's out there. I just
definitely know of the Oort cloud. That's definitely true. I think as I discreetly look at a different screen, is between 2,000 and 100,000 AU.
Some of the extreme,
So
there's different estimates, right? There's like different models. I guess I'm pointing to some of the more extreme estimates of it.
Oh, extreme.
Yeah, I don't know.
Could be, well, 100,000 AU was what, 1-2 parsec? Because it said
I think it's almost a couple light years.
Oh, sorry.
No, 1 parsec is 200,000.
1 parsec is 200,000.
We said 4 light years was 200,000-ish. AUs.
Yeah, but so 1 parsec is 200,000, and so 1 parsec is a little bit less than 4.2 light years.
But at any rate, the Oort cloud is a couple light years away in some estimates, I suppose.
Yeah, so it's like looking at the front page of Wikipedia, the Oort cloud is proposed to surround the sun at distances from 2,000 to 200,000 AU, which is beyond the termination shock and the heliopause. So it's so it's like something that's out there in between the stars and seems to be gravitationally bound to our sun. But it's weird that it's beyond the termination and the heliopause, because that seems like the way that I look at them is to be the limit of the sun's influence. But
well, that's the limit of the sun's electromagnetic influence. These objects are controlled by the gravity of the sun.
And so that speaks to the importance of the structure and the interaction of these ions and these plasmas, because you wouldn't expect gravitation, like if there wasn't this wall of interaction, you would expect there to still be an electromagnetic interaction at that distance, right? Like if you didn't have the termination in the bow shock, is there any reason that the sun's magnetic sphere influence would stop short of gravitational influence?